Good morning. Let me wait for a few minutes for people to join, and then we'll get started. But this is going to be interesting. Okay. 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 So we'll keep this a little bit fun this morning and go through it in a way that maybe kind of make it interactive. First of all, my name is Omer. We are based in Maryland, near DC. I don't know how many people have been there, but essentially, we're based out of East Coast. We support a lot of teams out for DevOps and SRE teams, and recently we've been doing a lot of AI work. So let me ask a question before we get started. How many people are actually building AI applications for their companies or themselves or startups, or have done any of Gen AI work recently that has been booming around all kind of in all industries? Any show of hands on anybody who's building AI or has pipelines that are building and churning out AI applications? I see a few hands. That's pretty good. But essentially, today's talk is going to be kind of interactive. It's going to go through a little bit of what AI, and specifically, you might have heard the word hallucination a lot, or how AI goes wrong. And we'll go through a little bit of case studies in terms of some fun stuff that's come up in the talk worlds, and we'll start to talk about how you guys, when you go back to your office, can take literally the controls and start building them in a way that makes sense to you. If you haven't heard of AI, and if you haven't heard of like literally what hallucinations is, don't worry about it. We'll go through all of that today. We have plenty of time. We'll talk about how to secure it, how to build it, how to actually automate it possibly. So the idea here is that, like I said, give me a moment to figure this out. Okay, of course, I haven't connected the dongle. So I have to connect that first. So yeah, this should work. Okay. Does it have to be turned on, or? Okay, give me 1 second. Okay, now it is. Okay, so a little bit about us. I'm not going to waste a lot of time. I'm going to actually go right into the talk. But essentially, we are a company of we are 4 different companies that are combined. But one of us is a consulting company. We also do a lot of funding. We do a lot of VC work around AI and specifically sustainable growth. But the 2 of the main companies that we do have are, one is called the Alpha Scale, which is all about DevSecOps tooling and to things like you might be using for SAST and DAST and automation of security. And the other tool that we have essentially is called the Oxen AI, which is a tool that allows you to do 3 different things, including how to build applications for AI very quickly. Think of it as like LangChain. I don't know if you've heard of LangChain, but essentially it will allow you to build around all 3 models or all 4 different models without having to write code for one. So it's kind of an abstraction layer. I'll let you browse through this, but this is just to kind of give you an intro about us. But what really is going on, and let's talk about, is hallucination. And I know a lot of people think this is like a negative word, or how it has happened. But we have to understand what AI hallucinations are. So as all of you know, when we are in the new Gen AI, new Gen AI world, what's going on is that you have these models there, and models are essentially a combination of 2 things: data and reasoning. And once you have your data and your reasoning that is working together, essentially you have something called temperature. And your temperature is what you tell your model to how to actually reason. It's very similar to, like, let's say when you get sick, and essentially what you start happening is that you think you're getting sick, you come home from work, and you come home and you realize, oh, I'm not feeling well, and you start taking, before you take any medicine, you start seeing things, and like, what is going on? In a lot of ways, hallucination is a lot like when you have fever, where your brain is processing too much data, too much memories, too much questions that you have in your head, and you're thinking, okay, what is going on, and you can't make sense. In many ways, Gen AI models are in very similar. They have a reasoning engine that when you feed data to it, or if you feed a lot of prompts and questions to it, it starts to get confused. So it's very similar, like if you were trying to tell somebody who was very layman about, who doesn't know about Gen AI, who doesn't know anything about hallucinations in Gen AI, it's very similar to telling them, hey, I'm seeing things. I'm like, I haven't taken my fever medicine, and I haven't actually taken my medicine, and what is going on? And essentially, it is very similar to how the AI model is behaving, because now is kind of getting confused because it doesn't know what data to take or how to actually respond to it. So in this case, it's very similar, right? Essentially, LLM models are essentially going in and processing questions that you're asking, producing outputs. You're doing something called RAG, which is essentially giving data to the model, which is extending the model's data itself. So that also can cause confusions. You are actually using things like how to integrate with other systems. So when you do all of that, essentially you can cause hallucinations, and they're very similar to just like how to take your fever and when you're getting sick and you're not feeling well. And the way how to kind of take care of it is essentially to stop these non-plausible sounding nonsense that comes out of the model sometimes. You have to basically make sure that you take your medicine. And what is the medicine for kind of producing and going around the hallucinations? Well, you have a lot of controls around that. And that is the kind of the concept that we will be discussing in kind of detail today, those controls. And the guys who are like the SREs, the guys who are the DevOps, the people who are at the boundary or the deployment teams, you guys are essentially the caretaker of that, right? You guys are the ones who are going to build the automation around the controls. Like you guys already built the automations around security for making sure the code goes through specific gauntlets or testing stages or things like smoke testing. This is exactly the same. So when you start building AI applications and guys are going to be automating them or building them to DevOps pipelines or building out tools that look at prompts or prompt guard, you want to make sure that this stuff is built in. And during the latter part of the conversation today, we'll try to focus on what are those exact things that you should be thinking about building those in. And hopefully this kind of relates to, hallucination, which is a major concept, and it is a major issue in LLM world, because all models, they're like nothing more than like 9 to 80-year-old brain and has a lot more data. So when you start feeding data, when you start asking questions, it can go in all kinds of different directions. And us who are people who are DevOps, our jobs are going to be eventually, and are already, is to control that boundary. So I put this slide. This slide is just for the people who want to take away or take a picture later. And all these slides will be available on our websites and also, I think, also on the DevOps Day Warsaw. But essentially, there's a couple of things we can do, right? We can kind of go ahead and talk about how we can stop these there's two things that can happen during hallucination. One, you can have inconsistencies, and two, you can actually give a completely wrong answer. And the AI models, they're actually capable of building, like they're generative, right? So generative by nature means that they are going to build out answers. So they can actually flat out build out false answers. And the false answers can literally be something that is not verified, and they'll make things up. The other one is that they can be very inconsistent, and the inconsistency is equally troubling, where things are not, well, we know they're not going to be deterministic, they're not going to be the same answer, but an inconsistent response can also lead to things that are going to affect your customers. So if you are building an e-commerce website or e-commerce site and you have a consistent experience, or if you want to have a recommendation system that is going to be consistent, if you use Gen AI, without the controls that we will be talking later, the hallucination can cause not only factual fabrications, which is just flat out lies, or my version of truth, but essentially the factual inconsistencies are very concerning. And I've given some examples on it. I don't really want to go through them per se, but like they're really can be very nuanced, right? They don't have to be completely false. They just have to sound real, but people who do know, they would know that's not true. So to capture this is really important. And how do you actually know what is causing the actual hallucination? So we talked about temperature. Temperature is something, literally a parameter that you put your LLM model, when you configure your model, or how basically it's usually a number between 0 and 1 of how much you want to give it a range of being creative, to be precise, not to be very general. There are things about the RAG data. The RAG data is the data that you feed, your data, that you're telling the model to compute on. So for example, a lot of the use cases that we see, actually almost all the use cases that you will see that are going to be in commercial world are going to be around RAG, which is basically saying that, hey, I know you have a reasoning engine, you know some base knowledge, but I want you to go ahead and start telling me answers and generate data based on my data set. So if you're like a high school, if you're like a college, I give you all the transcripts and all the transcripts of all the students. Now I want you to tell me how many students in our universities are graduating on time. Well, that's kind of like feeding your data, but when you feed your data, that's exactly when you can also hallucinate, because having too much data in anything, and that's like, when your brain is not feeling well, you're just having an overload. You need to be careful about that. The transformation of the training data, the data that's used to build models, is also equally important. And probably the biggest thing that causes all the hallucination, that causes all the inconsistency, is the prompts. The prompts are the things that the user, or the prompts are the actual questions that machine to machine asks to the model. And usually you have to realize that most of the LLM stuff eventually is going to be machine to machine. So these prompts are the prompt injections. For example, myself asking an LLM model, hey, can you build me a malware? Can you actually inject a malware? Can you test out a malware? Or even very basic examples like, can you go to this particular link and pull out the code? And that is one of the injection points that a lot of early attackers have done. They would just ask the model that, hey, can you go to a specific link that might be malicious? So before we go here, right, is this really important? It is super important. 56% of companies out there in Fortune 100 or Fortune 500, are already considering this. There already is something called Gen AI insurance. A lot of companies who are consumer-facing or are publicly trading companies already have purchased AI insurance. So this is something that is going to come down to, and I'm not sure if you guys are already seeing this, but when you're doing DevOps work, you'll see this, right? You will be the people who will be implementing those insurance and things. One of the big things that we recently saw was Air Canada. Like, essentially, they built out a bot really early, and essentially that would allow you to go after how to look up what the flight cancellation or flight or luggage policies were. And essentially, it would actually end up creating false policies that led to all kind of issues. And at the end of the day, they had a court case that ended up creating for them to go out and having to repay a lot of the customers who were overcharged. Links for the conference and all of this are in the bottom. They're small, but when you have the slides, you can go through them. But this is not a singular case of being Air Canada. There are 73% of companies that have already experienced an incident, and that it is involving Gen AI. Gen AI, I don't want to be generic enough and say ChatGPT or OpenAI, because we'll see some case studies in a minute. But essentially, people are developing them at such a lightning pace, such a quick, and this is because of how we have learned for everything from DevOps already. They're like, oh, it's the residual knowledge, already the investment we have made in development that we can start building things out. And people have built out things super quick. You have seen everywhere from car companies to airlines to having a bot that answers basic questions. And essentially, overall, it's just not Air Canada. Recently, all of these companies have some kind of an incident, and including companies that are are the pioneers for AI, including OpenAI and Microsoft. And Microsoft, as you all know, has Copilot. In fact, one of the case studies that we'll just discuss in a moment is about Microsoft Copilot. So a lot of these applications, a lot of these brand names are some I'm sure you already know, but as we go in DevOps world and open source world, usually the lesson learned from the big players are the ones that we end up actually pulling into our repositories and our daily practices. So I'm going to go and cover some of the actual few of the incidents that happened and talk about what really happened in terms of OpenAI hallucinations, and then we'll talk about the controls and how to protect against that. So one of the things that essentially is Slack AI was a tool that came out as part of Slack. I mean, how many people use Slack? I use Slack daily, right? And Slack essentially basically said, oh, I want to be able to do a tool that allows you to ask a question about your chat history and essentially build some kind of instruction to do something. For example, hey, I got a message from Michael. And he sent me some code. Can you review that code with the chat GPT, like some kind of prompt? Essentially, what happened in this particular attack model is, and this is not an attack particularly, but essentially a feature that was not designed correctly, is that, and Slack to the day hasn't really acknowledged this as a bug, but they have actually fixed it. But what happens is that once you are sending a prompt into the Slack AI engine, it doesn't know if it's a malicious or non-malicious. And for example, it can't generate malware or actually exfiltrate data and send the data out in an email or send the data to someone else. And essentially, what really could happen is that if I was a Slack user and if I was phished, that phished email could literally send if I clicked on a link, essentially would literally take the phishing emails prompt and send it to the Slack, and Slack would just literally execute it at privilege mode. And privilege mode essentially means that it can actually send and share your data, your messages, or your groups that you're in. And they talked about this, and at the end of the day, they have fixed this. But essentially what we learned, and two of the things that we have to build out, and when you're building out Gen AI technology for your teams, essentially is that, hey, we need to make sure there's content filtering, and we'll cover content filtering in a minute in a little bit of more detail. We need to build in prompt validation. And both of these things can technically be automated. They're nothing more than what you currently might be doing in some kind of SaaS or DAST or some kind of pipeline that reviews code. I mean, let me ask a question. Has anybody ever used TFSec or used any kind of tool that looks at code? Right? This will be part of your workflows when you build out AI applications, because hallucination is real, and you will need to be able to kind of automate this and build this out. Another big example is Copilot, right? Copilot is a future, right? Everybody just keeps saying Copilot is a future. Copilot will be the next big thing. It's already arrived. Microsoft built it in I don't know how they did it, but they built out an enterprise first-class solution for in their portfolio within 7 months. It's part of the Office 365. It's part of the GitHub Copilot, and it's going to become part of everybody's life, right? And everybody's like, oh, Copilot is really great, but technically, their Copilot also had a security issue. One of the security issues with Copilot that's really interesting is, I don't know if a lot of people know about ASCII smuggling. Essentially, you hide the actual content of a prompt in different ASCII characters, and once you get it in, you reformat it. And in this particular attack scenario, what happened was an attacker was able to phish a victim and send out prompts to Copilot. Essentially, Copilot wasn't looking at different languages, different language sets, different ASCII character sets. And once the ASCII character set was inside the user's Copilot, they were able to not only able to collect but exfiltrate data out. And as all we know, Copilot is one of the is going to be, and it already is, a sentinel tool in terms of what AI represents, right? And it has really pervasive amount of information. It can get to everybody's emails, Teams messages, and I'm sure if you're not using Slack, you're using Teams. So if Slack had an issue, Microsoft Teams had an issue, that's a coverage of more than 90% of collaborative tool market out there. And what that means is that people there are tools and there are commands and there's prompts out there that can trick the AI to not only collect, but also send out the data. And that's one of the things we'll talk about in a minute. The connectivity of the AI models and the connectivity of the AI systems is really important to secure, because essentially, not only if you can secure the AI is important, but you also have to secure how it's connected and what it can share. So the lesson learned from here, as we kind of go through, is content filtering we talked about before, but Gen AI phishing is something that we have to know about. We have to know about something about response validation. Whatever that comes out of your model, the response should be validated equally to what if you're validating the actual prompts. The RAG data control, which is what essentially is the bedstone of future LLM applications. I covered that already. But essentially, like for Copilot, what makes it really, really powerful is that it can actually extract and search over your entire data history in your Microsoft Office 365 ecosystem. It can go through all your emails, all the Word documents, your OneDrive. And just remember, Copilot is not an Office, your work thing. Copilot is already enabled for you on your own personal account. So, and if you have a lot of personal information in your Copilots, this is kind of like really scary, that somebody can actually send you a prompt that you might be using for Copilot and essentially pull out your data that might be your personal data, including, all kinds of things. So another example that I want to cover, and there's two more, is, and I'm talking about really major examples. I'm not talking about some small company. We talked about Copilot. We talked about Slack. Another big one was OpenAI, and OpenAI is the actual ChatGPT, right? These are the guys who are building LLM models. These are the guys who came out with the pioneering ChatGPT 3 and ChatGPT 4 and all these models that are just like everybody's been using. And I know there's others like Llama and stuff, but essentially, even these guys, whenever they introduce a feature around them, they're going so fast. They're building this stuff out so quickly that there's issues everywhere. And for OpenAI, essentially recently they built out a Mac application and Mac OS application, and Mac OS application in ChatGPT was able to, and this was not a Windows thing, it was a Mac thing, were able to inject spyware. And the way it worked was, and I abstracted a lot of detail here, and I'm just leaving the trails for you to go and do search. But essentially, there are links in the presentation. But essentially, you were able to, in the Mac OS application, they were using components, something called memories, and the memories is a component which allows their application to remember what the previous prompt was, and in this particular version of ChatGPT, OpenAI, Mac OS version, you were able to get into essentially modify the memory, and not only be able to modify the memory, but you can actually were able to tell the model the memories to kind of go in every future prompt and response to be sent out to another server. And somebody did that. Somebody actually went out and built this attack chain out. And when they built this attack chain out, they were able to start seeing everything from what the user was asking when they were using the Mac OS OpenAI version, and they were able to get all the future chats. Now, how do you get around that, right? And so some of the concepts that you might have heard of is like zero trust. So zero trust for LLM is very important, right? And zero trust for LLM, things like how do you integration access? How do you integrate with things like memories or things like cache or things like external external integration points like agents. So for example, an agent could be things that like you want to pull in the latest weather from Bloomberg, or you want to pull in the latest news from CNN. And if you want to pull in the latest CNN data, so you can actually allow your user to not only ask a question on the historic data that it was trained on, but the newest data from today, then you need to have those integration points. And those integration points are usually where you have a lot of issues. So things like least privilege, the things that we have heard and talked about before, things like how to actually avoid and look at memory and do validation of data that you store when you store it. And all of these things some of these things are application layer, I get it, but a lot of these things are DevOps things. And what you will start seeing tools like Prompt Guard, Oxen Security. We have a tool that actually does security for OpenAI. But what's going to happen is not about specifically about tools. It's about building out the process. So when your company or when you guys are building OpenAI applications, you should start thinking about how to automate and build these into your workflows. And this will be part of something that essentially will be ubiquitous or equal to how we do security today, but it'll be OpenAI security or OpenAI validation or OpenAI verification. Another example, and this was the fourth example I wanted to cover, is something called Email GPT. Email GPT came out right around the same time Copilot came out. It's a separate application. It's really cool, right? It essentially says, hey, can you write my emails? And nobody likes writing emails, like long emails. And some people do, but you know those people. But essentially, it allows you to write emails. And the way it would work is that it actually integrates with your email provider. So it would work with your Gmail, or it would work with specifically, it's an app. It's actually an application that you pay for. And how does it work? Essentially, the way it works is that you can phish a user of Email GPT, and if you were able to successfully phish them and they were a user of Email ChatGPT, you can basically, with one link, ask to generate an email on their behalf. Now, think about that, right? You literally have an application that has access to entire emails, and somebody else can generate an email on your behalf. And that's like scary, right? Because now somebody can literally use your name or use your knowledge, use your signature to kind of send out an email to anybody, because the tool says, oh, all I do is I write great emails. And essentially the way they generated this was they were able to kind of do a ransomware attack, and they were able to lock people out. But overall, Email GPT is an example of another DevOps thing that we do really all the time. I don't know if you guys use something like Twilio or a tool that actually sends out emails in your flow. If you use an email data flow, and eventually that company that offers you an email flow because of your application needs emails, and every application needs emails, right? You need to understand how, and they are integrating AI into their flow. It's very important to understand that how their AI works. If their AI can hallucinate, if their AI can be tricked into giving out data. So, but the general flow and lesson learned from here was that in the previous three examples, the issues were self-created application stuff. This was an integration, third-party vendor thing. So how do you actually do third-party Gen AI application audits? How do you make sure that if you are going to pull in an integration or an agent or a bot or an API, how do you know that API is going to be secure? How do you know as an SRE engineer to debug that? How do you know as a security analyst to go ahead and make sure that you can come up with a risk number for that? And that is part of the flow that is more human in the loop, but this is equally important as a technical part, that not only you have to build secure LLM applications, you need to have secure LLM integration processes that make sure you're not just pulling in somebody's code, or you're not just pulling somebody else's integration or somebody's API without some kind of validation. So another control that we think about and we want to look at is the Gen AI audit controls. So
there are more incidents, right? Gemini had it. Gemini's Google. They're here. NVIDIA had it. Meta had it. Snapchat had an issue. And all of them essentially are big names. I mean, these are things that we use. I'm sure somebody in this room definitely uses Meta or Gemini. And all of these guys are like literally one of the largest players, are like, large 10, 15 companies in the world. And all of them had issues. All of their chatbots, all of the AI chatbots had multiple issues. I mean, and I'm not going to go through all of them, but most of them issues could have been resolved. So I guess the real question is, how do we do this? How do we automate it? How do we build it? So not the greatest slide, but the idea is that to kind of this is the meat of the whole talk, right? If you want to take something away, is take away the controls that you should be automating. Take away the controls that you should be think about how to process through your own some kind of open source tool that you can use, or buy a tool, or just even human in the loop review process, right? So number one thing is content filtering. So usually LLM applications have content filtering. And remember, one of the things, and I'm glad I'm here in Poland, right? We work with a major bank, a global bank, and one of the things that they're building is something called a translation tool, because they have folks everywhere. And one of the examples was that, okay, we're going to use Microsoft translation in Azure, and we are going to use OpenAI, which is behind the scenes. But their translation tool is supposed to be able to translate to all languages. It can go from English to Spanish, Spanish to Russian, or go to Polish or whatever. The problem is Microsoft content filtering only supports 7 major languages. It only supports Spanish, English, Italian, French, and Japanese. All the other languages, the content filtering is known and advertised to be weak. So if I wanted to inject a vector, if I wanted to inject and ask, hey, can you generate me a malware? All I have to do is ask in Polish, because the content filtering barrier is lower in other languages. That's just one example. So content filtering, something that you can build at the application layer. You can build it if you have an application that has only a few amounts of prompts, let's say 10 prompts, because you have a machine-to-machine AI system. You can do that in DevOps world. You can actually automate it and make sure those are good. Another thing is prompt validation and sanitization. This is very similar to, like, if you remember, input validation when you write code. Everything that goes in, everything that should be going into your models, everything that comes from the user should be validated. And that can be done if you're doing a static kind of DevOps build, you can do it there. You can actually use a tool to do it. But essentially, if you don't have any kind of guards around your prompts, you are going to hallucinate. The amount of knowledge that the model has to generate in feedback loops, it is going to possibly give you factually inconsistent information. It might not be incorrect, but it will absolutely give you inconsistent information. The RAG stuff, the stuff that actually makes LLM applications really powerful, right? Things that you can actually use to kind of build out an application with your data. You need to make sure that your data it creates a data that is consistent also. So if you're going to give data, for example, for millions and millions of lines of data around, let's say, some kind of even DevOps process or logs, you want to make sure they're structured in a way that they don't actually themselves cause any hallucination. You want to make sure that the RAG data is stored in a way that it can be, when it's indexed or when it's actually looked up in using the vector model search, it is giving you consistent results. I covered this multiple times, but about the external sources, the external integrations, which I guarantee you, I promise you, you cannot get around. Because what makes applications around LLM really powerful, along with the RAG, is the external interfaces. What makes it powerful is you going to one LLM application, asking a question, and it collects the data for you, searches on top of your data. For example, it says, hey, based on my previous assessments that I've done for a company, can you do an assessment for a company XYZ by going to their website? So like if I'm a risk manager, if I'm a finance manager, if I'm somebody who does a lot of analyst work, I'm looking at things consistently. What I would like to do is build a report without doing the work. So I would say, hey, can you look at all my previous reports? That's RAG. Can you go to a company called XYZ in Netherlands and pull and build me a report or a summary just like my previous reports? Now that's a combination of going out someplace, looking at your data, and doing generative AI work to build you that report. That connection to the internet, that connection to a service, that connection to an agent, the connection to another bot, and that connection to another AI application, that integration point is super important to secure. How can you do that? You can actually build out pipelines and automation in your DevOps to run validations against them. You can ask and build out your own internal systems that can do filtering and actually content filtering and even sanitization of data with your own tool sets. As much as the inputs are important, outputs are equally important because the user only sees the output, right? Or bot to bot only sees output. So regulating the systems, for example, one of the attacks we recently saw was somebody asked a question, can you give me an API key? Right? Can you give me the key that's stored inside the system? And somebody did. And so responses validation is also very important. Zero trust concepts. I'm not sure how many guys are in the room actually been doing a lot of zero trust validation or security, but that is also equally important to make sure that at every integration point, every point where there's a trust boundary, there's a threat boundary, a threat model, you actually perform what's called zero trust validation. Whatever you save in LLM memory, and this is a concept that I think is very important also from privacy, not just security. The memory, which includes your previous prompts, includes your previous responses, includes your responses to your integration points, needs to be equally secure. How do you validate that? How do you have your keys? How do you segregate? How do you actually make sure that my data or my memory is different from other users? One of the ways it was very openly caused hallucinations is when people start having crosstalk, which means is that my memory or my prompts are influencing other people's responses. And last but not least, how do you actually do generative AI application anomalies? So all the way from I know a lot of people in this room probably are familiar with SecOps or things about how to do anomaly validation and how to look for issues or vulnerabilities. There needs to be a process, and if you don't have one, there's a bunch of frameworks online, like OPSOP Top 10 has Gen AI Top 10 list. Take a look at that top 10 list to build out applications that are already secure. So overall, I'm just going to kind of try to wrap this up, but essentially, I will go through 4 different. Now that I've covered the security controls, I want to show you the security controls in kind of action, right? And so one of the things is prompt injection. How do you secure against prompt injection, right? What is really going on, right? Bottom line, show me in action, right? So somebody, there's an attacker, right? And this guy is trying to send malicious prompts. One of the things you can do, or you can do it either in pipelines and automation if you have a static application, or if you have a dynamic application, you can put it into the sanitization or the prompt validation, meaning you need to have a boundary of what your application should accept. The other thing you can do is essentially use contextual and role-based access controls. So not every application user will should have equal privileges. So if you have a user that's asking you to go online and look up something and pull the data in, see if this user has access to that bot or memory or integration point. You should actually use unique delimiters to actually make sure the user prompts are within a boundary of known valid prompts. And that's contextual, right? We talked about contextual. You have to know what application you're building. If you're building an application that only takes financial data, you can kind of make sure that. If it only takes log data that's within CSV files, you can do that. If it only takes data within Microsoft Word, you can make sure that Microsoft Word files are correctly formatted. Now, this slide is really busy, I know that, but this is only for how to do RAG, and RAG is super important. I wanted to cover it. But I literally built out a very detailed decision tree on how to secure it, right? All the way to like, do your system uses RAG, and RAG meaning retrieval augmented generation, like being able to use your data with AI. And if you do use AI and you are doing it, do you need to kind of go ahead and do you actually validate your responses? Do you actually go ahead and build out the contextual stuff? And I'm not going to go through all of it, but this particular slide essentially is for you to take away with and be able to go and kind of run this decision tree. And this decision tree is in a way a heuristic model that will allow you to code it into your pipeline or code it into a shell script or code it into a Python script against somebody's AI code. And you can run this, and when you run this, you should be able to validate a user's code or system. Now, the next thing I really want to focus on, the fourth thing, is how to protect and secure memory. So what happens in an attack against the memory is the memory is manipulated by a user because they're able to phish you or able to get into your, being able to get into your OpenAI or, your GenAI application. And what they are basically trying to do is they're trying to essentially hijack your session. They're able to hijack your session and be able to use the data that you have stored in your GenAI application to pull it out and be able to use it. How do you protect against that, right? So there's a couple of things, right? You can do input validation. Something very simple. I mean, the things that we're talking about, in some cases, sound simple, but require a little bit of contextual knowledge and business knowledge. But the attack model is very similar to what we used to see when we were building out SaaS applications or web applications. The other things you can do is you can put memory segmentation. Essentially, you can session or limit the user, just like how browsers do session management. And I'm not sure how many people know about session management in browsers, but you can do GenAI management, session management of memory. So if I'm a user and you're a user and we both go to Volkswagen's website and there's a chatbot, and there's a chatbot on a Volkswagen website, and you can ask, hey, if I buy a Volkswagen XYZ model, do I get heated seats, versus the same user asking a different question on a Volkswagen's website about a different model. They should be segregated memories. And that's a very naive example because there's no literal flaw there, but that's exactly how you get hallucination models. And once you get, because the models, remember, are shared. There's one model that all the users use. There's not separate models. What we are differentiating is the different memories, the different integration points, different prompts, different responses, different content filtering for each user, which is a session, but the model itself stays the same. And if you want to avoid the hallucination of the model, it becomes super important to make sure the sessions of users are managed separately. Last but not least, I'm gonna cover this, and I'm gonna save about 15 minutes for questions. Is secure integrations with the LLM model. And this is really important, right? If you're building a knowledge base, if I'm building a customer, a system that basically allows them to remove the help desk, and so now rather than calling someone, they basically go and ask them, okay, what is my HR benefits? Or how many days do I get off? Or how many days do I get? How much money do I get for my courses that I take from a university? Or I want to go to DevOps Day in Warsaw. Is that covered in my part of my education or my plan? That knowledge base, that actual bot, that actual application, it has to connect to I don't know if you guys use Workday or ServiceNow, right? Or I want to create a ticket that essentially says, hey, my computer fan is not working. I want to create a ticket through a bot. Essentially, to create that ticket in ServiceNow, you need to connect your bot, which is your GenAI application, to an integration point to ServiceNow or Remedy or whatever you use. Those particular endpoint integrations are super important because that's where a lot of attack happens. They're essentially your applications are the gateway point to a lot of the attacks because to the back-end systems. So unauthorized access, unauthorized manipulation, excessive agency. Excessive agency is an example of where you are giving too much privilege to an application that you can do a bunch of things in the background, right? And how to protect against that, right? The way you protect against that is you essentially start thinking about least privilege, how to get the least amount of privilege, or being able to control the access to the application. Another thing is you can do a lot of monitoring and logging. You can actually start creating logs that you can process and find issues. And I know we're getting right to the point. I'm going to stop right here. It's about 45 minutes. I want to stop here, see if I have a lot of questions. I've been speaking a lot, and I can go back in the slides if anything. But essentially, we do publish a lot of material online from our companies. We do a lot of talks. We're doing a workshop in Munich and Berlin this year for about 5 hours a day on AI. We do a lot of security stuff. Let me pause here and see if anybody has any questions, and we'll go through that. We have about 15 minutes, so we don't have to rush out of the room. But I hope you saw some things that you can take away and go back and think about. Questions? Okay. So, Pedro, do you want to take it back, or okay? So, slides will be online on oxen.io, and if you guys have any questions about them, or if you have any questions, I'll be outside. I'll be happy to answer anything in private. And I hope you learned something. I'm looking forward to some of the talks today, but this will be a great time in Warsaw. Thank you.